The tunnel you are seeing is not an ordinary tunnel. It is, in fact, the world's largest tunnel that passes under the sea. This 50-kilometer-long tunnel is that mega project, which engineers call the seventh wonder of the world. The main reason for this is its construction. Working with 13,000 workers altogether in extremely challenging conditions, and to excavate a part of the ground, upon which the weight of the whole sea is bearing down. One small mistake can fill this tunnel with water, and can bury both humans and machines forever. And that too in just a few seconds. Welcome back once again to Docutainment's videos. Viewers, about 13,000 years ago, when the last ice age was coming to an end. So it separated today's England and Europe from each other. The reason for their separation was this part of the sea which is now called the English Channel. Although this channel is quite wide, it becomes quite narrow at this point. And at this point, England and France are only about 33 kilometers apart from each other. Many times in history, attempts have been made to bridge this gap. But these experiments were stopped after many lives were lost, because perhaps the technology was very limited at that time. But by the end of the 20th century, when technology was advancing rapidly, then once again, it was thought of connecting England and France by land connection. It was the era of the 1980s when it was possible to build larger machinery. Apart from the machine, there was another challenge, and that was to convince England. Yes, the cold waters of the English Channel have always given England a heavy hand over its enemies. From Napoleon to Hitler, many enemies of England planned to capture it. But it was the harsh conditions of the English Channel that always gave England the upper hand. In World War II, Hitler, from a village called Calais in France, launched a secret project to dig an underwater tunnel so that they could gain control over England. However, this project could never be initiated. Well, after Hitler's death and World War II, significant changes began to occur in Europe. The business started booming and prosperity was everywhere. France and England, who were once enemies, started trading through the English Channel. As time passed, in 1986, both countries decided that now they would remove this barrier and connect England with Europe. There were many protests in England against this decision, because many people took great pride in England's island sovereignty. After several months of long talks, both countries finally agreed to build an undersea tunnel. It was named the Channel Tunnel, which is often referred to as the Euro Tunnel by many people. It was agreed that teams from England and France would dig the tunnel from their respective sides, and both tunnel segments will connect at the center points. The project looked like a colossal failure even before it started. Constructing a tunnel approximately 38 kilometers long beneath the sea, it was not a task that any engineering firm would dare to undertake. Eventually, it was decided that 10 engineering firms would collaborate to construct the project. Before finalizing the design of the Channel Tunnel, it was essential to know which type of transport would run through the tunnel, where the tunnel would start, and where it would end. It was decided through mutual understanding that a total of 3 tunnels will be built, in which a railway loop will run between England and France. One terminal will be in the French city of Calais, while the other terminal will be at Folkestone in England. The total length of the tunnel will be 56 kilometers, out of which the underwater part will be 38 kilometers long. Finally, in 1986, the construction of the Channel Tunnel was started. The biggest challenge the engineering team had to face was the tunnel boring machine, also known as TBM, because before this, there was no project like this ever built. That's why a TBM of this particular diameter was also not available. First, this TBM machine will have to be built from scratch. Thousands of miles away in Seattle, Washington, the Robbins Company was commissioned to build this particular tunneling machine, who are experts in making boring machines. Once completed, this gigantic machine will be 800 feet long and weigh 1,500 tons. Its diameter will be 50 feet, with multiple sharp-edged blades made of tungsten carbide at its front. The hydraulic legs attached to it will push it forward. A conveyor belt will be installed inside the machine to remove soil and crushed stones from the outside, which will carry the debris to the service train. And then this train will take the debris out of the tunnel. This tunnel boring machine was a marvel in itself. The old technique where mountains were blasted to build tunnels. In comparison to that, this machine was a significant blessing for developers. But this technology also brought along many risks and challenges. If water leaked from somewhere during the 250-foot deep underwater boring, so its pressure will be so high that it would drown both man and machine in a matter of seconds. The survey revealed that there is a layer of chalk beneath the seabed on the England side, which will prevent water from leaking into the tunnel. But on the French side, there are many cracks in the seabed where this TBM won't work properly. For this, a decision was made to build a new TBM separately, which, along with tunnel boring, will also be a submarine. It will be able to withstand as much water pressure as World War I submarines. When this machine was developed, it brought a new challenge with it: how to deliver it 200 feet below the ground. The machine was disassembled for this task, and each piece was separately taken down below. It had to be reassembled after going inside the ground. It took several months and millions of dollars in expenses. 2 years had passed since the project started. Construction work on both sides was finally initiated in 1988. Disposing of such a large quantity of soil and rock debris was a mammoth task in itself. The machine was cutting 750 square feet of stones in a single day. About 2,400 tons of debris was accumulating. On the English side, the wreck was built into a country park called Stamfire under the Shakespeare Cliff between Folkestone and Dover. And that's why it slightly protrudes from the coastal line. The debris collected from the French side was in the form of mud. An artificial lake was created by pouring it into the Fawn Pigeon Valley near Sangatte. On the one hand, so much debris was being taken out of the tunnel. On the other hand, there was also a lot of material being taken in. As the TBM, tunnel boring machine, progressed at the same speed, sealing the loose rock and chalk layers was also crucial. Because if the seawater above made way for the tunnel, then it would become impossible to stop it. For this work, round concrete slabs of the size of the tunnel were fitted. This concrete is even stronger than the concrete used in nuclear plants. About 750,000 concrete slabs were used in the reinforced steel channel tunnel. The weight of one full-sized concrete slab is equivalent to 40 tons. That is, this total is as much concrete as 8 buildings like Burj Khalifa can be built. They were put on the service train and taken to the tunnel, where there was a special machine that was fitting them in place. Several weeks passed, and then months. The tunnel was slowly progressing forward from both sides. Everyone was eagerly waiting for the moment when these two tunnels would meet each other. Although it may seem simple to watch and hear about, in reality, it was quite complicated. If the two TBMs are not advanced in the right position, it is obvious that the two tunnels will never meet each other under the sea. For solving this issue, the laser beam guidance system was used. One laser was installed in the English machine and the other in the French machine. Both guidance systems were wirelessly connected. Whenever one of the machines changed its position, the guidance system sent a signal to the main computer to change the position of the head of the boring machine with a hydraulic jack. As a result, both tunnels realigned with each other again. Whether this guidance system was working properly or not, to confirm this, both the machines will be shut down in the last 100 meters, and then a steel rod will be sent to the next side to confirm whether the position of both tunnels is accurate or not. After 3 years of continuous boring, finally, the moment had arrived, when only a distance of 100 meters remained in between, and according to the plan, a steel rod was sent through. The positions of both tunnels were almost accurate, with only a 10-inch difference, which aligns within an allowed limit. Now, the engineering team faced their biggest and toughest challenge. It was very important to make one of the two TBMs commit suicide. Yes, because 2-foot thick concrete slabs had been installed in both tunnels. That means the tunnel diameter had reduced from 50 feet to 46 feet, and the diameter of the TBM-A boring machine was 50 feet. After the completion of work, a 50-foot machine cannot come back out of a 46-foot tunnel. Therefore, the solution to this problem was derived that one of the machines will have to be removed from the path, what engineers call mechanical suicide. So this sacrifice was made of England's TBM. It was tilted by changing its angle towards the ground. After descending several hundred feet, it was left there, where it is buried today. Now the final moment of construction was near. The French TBM went ahead and finally met with the English tunnel. And upon reaching there, the French TBM was dismantled and taken out. Now you might be thinking that English TBM could have been disassembled too. So why was it buried then? In reality, it was costing as much to disassemble the boring machine. With lower costs, a new machine could be made instead. That's why the company first assesses which option will incur less loss. Based on this decision is made, whether to bury it forever or to take it out again. For the first time in 13,000 years, a land connection was about to form again between the two countries. As many workers were working for this event, one worker from each country was selected. They broke the last layer of chalk manually with a jackhammer. And for the media event, they exchanged flags with each other. Thousands of years ago, after being separated due to glaciers, finally, England and France reconnected once again. It was indeed a significant achievement, and to celebrate it, a grand celebration was held. After years of hard work and sweat, the effort finally bore fruit. After completing the finishing work, the Channel Tunnel was finally opened on 6 May 1994. If the expenses incurred on this project are adjusted for today's date, so it will be £12 billion. During the peak of construction, around 13,000 workers were working on the Channel Tunnel project, while 10 workers lost their lives due to accidents during the construction. There are 3 tunnels in total in this project, 2 for trains, and 1 small tunnel is also constructed, which is used in emergency. Today, around 60,000 passengers use this tunnel every day, which includes 4,600 trucks, 140 coaches, and 7,300 vehicles, which are parked in the cargo train and made to cross the tunnel. I hope you will like and share this video of Docutainment. Thank you so much for your kind comments. See you in the next awesome video.